So guys, in this question we have to find the total deformation of a steel rod using the finite element method. So this is the steel rod. At this node the 30 kPs of force is introduced, and we having the two rod different area of cross section, like this having the A1 area of cross section having 0.1 inch square, and this will having the 0.3 inch square. So here the load is acting in this point and this point and this point. So here the 75 kPs, and at this point it is 75 ps. 45 kps it is subjected to the right hand side force of 30 kps. 12 inches dimension of this at this point of force acting given dimension, and this 12 inches and this is 16 inches dimension. You have to find the total deformation of steel rod using the finite element method. So how should we do that? We are just introduced at the q1, q2, q3, q4 are these are the right hand side acting forces. We are having the nodal displacement, or E. Young's E will having the 29 to 10 6 psi. This is a material property. Now how we can do this question total deformation by using the finite element method? Now first we are having to find the element stiffness matrix of each element. So we have three elements introduced here. First, finding the element stiffness matrix. So ke1 of first element, like EAL by 1 minus 1 minus 1 1. This is the formula. So E is the material property, A1 is the area of cross section of first element, and length is the length of the first cross section. So 29 10 q 6. So after we substitute we get this value, and we have to make it like 10 raised to power 6 common values from both of three elements to make out this. Like similarly is ke2 we EAL by 2. Similarly E will having the same value, but area of cross section will be like same. Area of cross section for the second element will be same as the first element, but length will also same. But in the case of the third element, we are having the area of cross section changed to 0.3 inches square, but length value is also changed. Just having the these values are same, we can see, and another value 10 raised to 6 is also same. So how now after finding the element stiffness matrix of three elements, now we are going the global stiffness matrix by adding that k assembly. How the k assembly matrix is formed? Like we have to add that matrix at this place. So this is a 2.175 this matrix 2 cross 2 matrix will this like this 2 cross 2, and this value is add. Listen, 2 cross 2 matrix, and here 2 cross 2 matrix and 2 cross 2 matrix also. So this value 4.375 with just adding this value and this value and this value. Or there is another method is the point mark point 1 2 2 1 2 and 2 3 2 3 or 3 4 or 3 4. Just this is the element, so having the one node and the second node, so like 1 2 or similar repeat 1 2. Now for second element we having the 2 3 node, 2 and 3, 2 node and 3 node. So we having the 2 3 and again 2 3. Now for the third element, so sorry again for first element is 1 2 1 2, and second element is 2 3. So we are having 2 3 and 2 3. Third element is the 3 and 4. So same here, third element 3 4 3 4, and here we will substitute the 3 4 value. Now the global stiffness matrix by adding all these values by 1 2 3 4 and 1 2 3 4, adding this value. Now applying the boundary condition. At what the boundary condition we find at the q1 value equal to 0. So boundary condition q1 value equal to 0. So the boundary condition q1 value simplifies the cut the first row first column of this matrix, only we get this matrix. So just put this matrix here, and 10 raised to power 6, that is important, that we are common out from 10 raised to power 6 is there. Now applying the kq equal to f, that is the stiffness into displacement equal to force. Now these are the, after applying the boundary condition, these are the q2 q3 q4 values are there, but having these, now the forces are there for second and third and fourth. For second, the right hand sides are taken as a positive and left hand side are taken as negative. The second force is q2 value 75 kPi, so at 75 10 to 3 psi, and here q2 is 75. So here write the q2 as 75 positive psi, and third q3 value is left hand side 45 kps, 45 ks and negative sign. So 30 is that force of 30 kps right hand side. Now similarly, now how we can solve this matrix? By just applying the kq, finding the inverse of this matrix by using any calculator. You find the inverse of this matrix, just multiply this inverse of this matrix again here. So inverse into a matrix will cancel out, take 1, and just pre-multiplying this in this side, multiplying a inverse and divide by 10 raised to power 6 and 3. So we get the q2 q3 q4 values, and after finding that q3 q4 q2 value, just find these are the, just like here inverse tending to 1, and these are the inverse of this matrix. So multiplying this matrix 3 row and 1 column. We get this. These representing the Q2, Q3, Q3. These are the nodal displacement. The Q2 representing the nodal displacement and point 2, Q3 representing the nodal displacement. The total axial deformation will be what for the steel rod is like Q2, Q3, Q4. These are the axial deformation in inches. Thanks.